just as it would do on your ordinary computer, and you will get like a window like this. It asks for setup. No, we do that later. We don't need that now. Go to File. Go into what's known as, okay, go to this PC. Go to Local Disk C. Go to Mentor Graphics. Go to the sample file that we uploaded here. And then you're in business. Okay. So I'll ask you guys who have a Mac or somehow have managed to install the LED on your own computer to use this option here. So I'm just going to log out again because I'm going to do this from my own computer. Okay. So I just go close. That was easy. And just edit like this. So it's a slightly better resolution I have on my own screen than I got on that virtual computer. That's why I prefer to do it. Yes, any questions?
Please, I have a lot of interfaces for L-Edit. For example, L-Edit Viewer, L-Edit Photonics, and other.
Just L-Edit or LED. Choose the LED icon.
Ah, L-Edit, I see. Okay, yeah.
Yeah. Okay,
LED,
we'll
yeah.
work on this one today.
Mm-hmm.
So I'll let all of you guys open L-Edit now, and if you haven't managed, please let me know. Okay.
Erik, can we start the recording, please?
Documents, not. Let me see. This is the one. And let's.
Sorry, could I ask a question?
Tutorial. Any questions?
About the.
And let me see. What did we actually run? Here we are. Okay, I put everything into that. So what we do then, we go to Oversikt, the edit part here, and installation guidelines PDF. So I open that one. And let's scroll down. So I presume then we have already done the installation part. And you want to do the licensing part. So what you do then, you're having on Mentor, you have what's called setup. So, okay, maybe if you installed it, let me have a look here. Uninstall Mentor batch tool, Mentor interface. Where do you have this? Help manuals, waveform.
I opened the one called Batch Tool again, and you got the interface back.
Hang on. Okay, fantastic. So the batch. Okay, the batch tool it is, right? Okay, at least I just wanted to check where it was. But then you have to go on to. Let me see. So you need then to go to this manage licensing part and then press configure licensing. Okay. If you do that, you go to point to license server, right? Is it easy if I show it here rather than, or is it okay the way I'm doing it now?
It's okay.
Yeah.
This is the next step I was wondering about.
And then you putting in then this code here, 1717 at lower capital S155.hpv.no.
Okay, that's on me. I thought it was an example. I didn't think it was the actual thing.
No. We're going straight on the actual thing. Yeah. I'll ask you to verify the license or something, or check that it's okay, and then you press next. Right.
Yeah, then I got
then
it.
you
Thank
get
you so much.
yeah. So this is the server valid part, and once you go out, you want then see more licensing? No, right? And then you just go exit, and then your program should be up and running. And it's this icon here that you are activating, not the LED MEMS. It's the LED X64, right? that is starting the program. So I guess if that's the last person who started the program, then I think we are clear to go, right? So what I'll do then is that I'm going to go back.
Just have a
Simply just press home, and it should center directly into the pattern. So if it's out of alignment, you just press home and you will see it. Home key on your computer. And zooming in is plus and minus keys, right? And you can do so also by, I think, having press set and the mouse button will zoom this window in. And if you are taking the negative, it will go out, but positive will go in on the mouse button. So you can use the mouse, but you have to press the set key on your computer at the same time, or your keyboard. This is just for navigating around. Okay, these are the basic things that you need to know. But everyone, I want you all to have this window here, and if you don't have it, then let me know.
okay, when I
in the same file. So we would like you to have one of these cells that will be governing these ports, right? So you define the size of the ports that's given here. Then you're going to move on and have another cell. Okay, so this one, yeah, that's how it works. Right, great. One for the mixer. Then you're going to have one for the mask. And of course, I've got one for the microchannels. So there will be 4 different cells together. So the idea is that you're designing the microchannel, the mixer, and the inlet ports in separate cells. We'll collect them all into one final cell, which will be your mask. And the reason we're doing so is that you can then afterwards perform changes on your, say, mixer or microchannels without affecting the other parts of the design. The problem is if you design everything together, that you can do also in one cell. That means that you cannot, if you're going to change the size of the inlet ports, then you need to change the size of all the inlet ports. If you're importing one of the cells with the inlet port in, then you can only, it's enough to change the size in the cell and it automatically update then in that final subfile and where the mask is. You're changing one, and they will automatically update in all those other parts that you have imported in the final design. You need to know, but I would very much like to also touch the edit folder. Then I have given the sample file itself. Datasheet is just a background on the program. The short keys are very useful because they are telling you how you can navigate in the document. So for instance, you control W and such, open or close or copy selected objects. But for instance, set here, right? And the mouse button, you can zoom in and out. Home is to fit the active cell to the current window. That's something you may like to use because you may navigate out of your design and wondering, where am I? You press home and go back to start. So there are, showing you here then how you can navigate around. So this recommendation for you guys to print this thing out and use this as a kind of reference when you want, okay, how do you actually perform different operations? So you don't need to always use the icons and then guess where what they actually will do. So people who are using this to design regularly, they are of course using this kind of keyboard shortcuts when they do the design. The outer rim or the outer rim here is actually the full extent of the wafer. Okay, the circle inside is the practical area that you can use. There's always be a section between the outer rim and that area that is rendered not usable. You'll find that when you're doing the resist deposition, that there's always been an edge at the very end due to capillary forces, actually, in fact, which the resist is thicker. And it's always a danger to put the design to the very periphery of the wafer itself. So the practical use is the inner circle. Then we have the center in the middle. I always recommend people to have a reference point when they start doing a design, that the center, the 0, 0 point. You will find here the coordinates up here. And also important thing to know is that the units that you are using, so millimeters is a good starting point. As we move down here, there are some horizontal lines, and these are normally marking the flat edge of a wafer. A silicon wafer will have a flat edge. Normally, the 100 wafers that most commonly used will have a flat edge, or the major flat edge pointing downwards. And these are assigned then normally the reference of one of the crystal planes. So when you do a design, and the design is dependent on the orientation of crystal planes, you always need to align your design with the flat edge. And therefore, in your mask, you should have, it depends on sometimes how far up the flat edge is going. So it's 2 different reference points here for you to use. Normally, you can recommend using the top one. At least then you have some space to the flat edge of the wafer, and you can then measure distance from your flat edge and the flat edge of the actual wafer, flat edge of the mask to the flat edge of the wafer. So that's why you have a flat edge at the very bottom. So normally in the end, you will put your design into this 4-inch wafer, or you're using 4-inch wafer as a reference to know how far, how big can I actually make my design? Will it fit in on the wafer or not? But before going to that point, you need to start your design, and the best thing is to go to Cell, and you go to Cell New, and then it will automatically have a Cell 1 name, but let's call that inlet ports, for instance, so you at least know what it contains. And then you will have a suddenly new window, and you see that your 4-inch wafer has disappeared, and you're now on inlet ports cell in thick letters, right? So go to 4-inch wafer. There we are. Then we see the 4-inch wafer. Press home. Sorry, that was the wrong button. Home, you will see the whole thing. Inlet ports, double click there, press home. You won't see anything because you have nothing there. But what you will see, that is a small cross here, and the small cross down here is marking the center of your design, right? So if you are accurate enough, you can see the coordinates up here. So if you come close to the center here, right, it should be 0, 0. In order to make such an inlet port, what I always recommend students to do is that, okay, what is the major shape? Is it a line, or is it a circle, or is it a square, or something else? And if it's a circle to do, you just press circle like this. And I want to align my circle in the center. Now, that's a kind of a tedious job if you're going to do that manually. So what I normally do, I just draw a circle like this. And as long as the line is black, it means it's active. Then you can go to Edit up here, and you go to Edit Objects, or Control E, and you get the window looking like this. And what it tells us is that the center of your pattern is now, because I just drew it by chance, it says it's minus 4.745 in the X direction and 6.6 something in the Y direction. But I don't really want that. I want it to be in the center, right? So I correct this to 0, 0. And then the question is, how big is the circle going to be? And when I'm think from the design specs on the tutorial, it said something like 3 millimeters. So then a radius of 1.5 should do. It's important then to check what the units are. Is it millimeters or is it microns? Then you can easily do a mistake if you are not aware of this. Press OK, and you certainly have a circle 3 millimeters diameter located in the center. Press home and you will see it. Now it's still active. Of course, it's black. So if I press the mouse key here, now it's blue. And it's not active anymore. That means you cannot do any edits. But if you want to Oops, let me just do escape. That I don't need. Going to press this, and you want to highlight it again, then just simply drag the mouse. You highlight it, turns black. Do Control E. Going back into this window, and I said I don't want special layers. I want to have a well-defined layer. Let's call this metal 1. Press OK, and you're having your inlet port. Okay. You then press File, Save As. You may want to save on your sample file, or you want to save it on a different name, so you are at least keeping your sample file in for a future reference. But let's call this micro mixer. And then you have to decide where on your computer you want to store this, right? But you can store it in that folder that I'm storing it in my tutorial folder here. Lagre, save. And then I have this saved as a special file, and then I can press, save all button now and again to make sure that when I'm doing updating my design, I won't lose it if it should crash or anything like that. So this, I think I'll stop just now. All the course contents are actually collected in here, and when I'm putting my I use this as the sample file because it contains all the layers and things you need. If you can, of course, just start designing from scratch, but then you have to start defining layers, and it's a big job. So I always recommend having a sample file. So we are using a sample file, and we start designing from that. Okay, and keep the layers that are visible. So that's such as metal 1, metal 2, metal 3, and so on, right? And the reason we're using different layers, we're going to come back to later as well. But in a complex design, you maybe want to have one layer as a base layer of metal, and then you have a mask with a different layer, which will be the second mask, for instance. So you don't mixing these masks together. So one mask has one layer, second mask has a second layer, and third layer, and so on. And you can have designs that has 15 layers, right? And so on. So once you highlight the object, you do this, and it depends on how complex the object is. You will get the window. A circle is relatively simple. It's just a position, start center position, and a radius. And then you can choose between your different layers here, right? So if you choose a metal 2, it will look like this. If you want to choose a metal number 3, right, will look like this and so on. So, and in fact, you can choose any of these layers you want. The special layers function is kind of undefined, so that will actually not give you. I'm wondering how that's going to work if you're submitting it like this. Some of these layers are actually just for writing or labeling and so on. But you have a whole range here. So we are only going to focus on, you can just choose poly, right? But poly is normally used for polysilicon definition in microelectronics. For us, it doesn't really care. We just need a layer that we define, and we know that the design is on the same layer if it's going to be, say, connected together on the mask at the very end. So I tend to use these metal layers. I feel they are easy and quite visible also. Just want to see what it says inside hierarchy level. Go design navigator. Maybe further down. That's not the one. This says design under layers, object layers, design navigator. Try that one. No, a little bit further down. One more, and one more.
Layers?
One more.
Oh,
that's
okay.
The one. Try press that one. Yeah.
What happened? Let me.
Yeah, then the design navigator. Yeah, you have that there, but if it
where you see where is the fault, go to the right, up to the blue square, to the right, yeah, and you see the arrow. Clicking the arrow.
Okay.
Yeah, add or remove buttons, drawing, and circle.
Thank you.
Fantastic. Yeah,
Are you
that's the easy way. Then you can, yeah, you need to highlight it. So you need to click on it. What to do? Go back to the arrow. That's the one, yeah. And then you just click on that one, and then you go to edit. That's one, and going down to objects. edit objects, go further down, that's the one. And then you can start putting
0.
in then what channels. And in order to do so, you need then to make a new cell. And we do then a new, and we can call this micro channels. I'm just following the names given in the tutorial sheet. And you're right, micro channels can also be the mixer, but in this case, you want to draw the inlet channels. And the easiest, you can have two ways of making channels. You can actually draw rectangles, and you have a rectangle function here that will allow you to draw rectangles, and you can then go in and control E, and you can specify the x coordinates, right? And in terms of x coordinates, you can then specify how long it's going to be and how wide it's going to be as well. But it's an easier way to make micro channels, and that is to use the wire function. And the wire function you'll find up here. So this is called all angle wire. That means that you can actually draw it at any angles you want. And again, we had the center point down here, and I always like to use the center as a reference. So if you like the wire to start from this point here, then you can simply click, and you have wire then that comes from a cursor as in any drawing program. And the question is, well, how long and which angle it's going to be? Well, I don't really care. I just double click, and that's my wire. And I go back into Control E again, and now we have a slightly different window than with the circle, because it's wires, you have x and y coordinates and so on. But I think I will again like this to start at the 0. Let me say that our starting coordinate is 0, and 0y and 0x. And then the question, how far out it is going to go in order to make then a 3 centimeter long wire. So of course you can tell it, well, it's going to go 3 centimeters in X direction. So that would be 30. Hang on. 30 minus. And then you don't want it to go anywhere in Y, so it becomes a 0y, right? And if you do this, the Y looks like that. But you want to have two inlets, so you want to have an angle. And the easiest thing to do so is to go back in again and say, well, which position do you need to wire to stop to make it a 3 centimeter long channel that is angled 45 degrees to the reference plane? So it's back into Pythagoras, isn't it? And find out how long are the catheters on either side of this 3 centimeter long hypotenuse, right? So the square root of 3 is 1.7 something, isn't it? So the best thing, of course, is to say, okay, cancel, and go into my calculator and just get that completely clear. Or 1.73. So given that this is millimeters, so it should be then 17.3. And then the same thing should be in the Y. Okay, and it gives you something pointing that direction, right? But you really want it, if you're going to follow the sign, it should point then, let's say, negative X. And now we suddenly have Y that's 45 degrees aligned, and well, you have the reference point, 0, 0 will be where these wires will meet. But in order to go from wire to a channel, you need to add a width, and this is given in millimeters. So if it's 100 microns, it's 0.1 millimeter. You have a width, and if you would like to use the same layer as you did for the inlet, then you choose layer 1, and suddenly here you're having then okay, hang on. To go back into arrow mode here. You have a wire that is 100 microns wide and 3 centimeters long, and so on. Press save, and you won't lose your work.
The recording has stopped.
Okay. Just a small. So you see here that's a line in the center. and the line on the edge, and this is a gap between, or gaps here, extension between the center line and the end here. So if we go back into my edit tool here, this is what's known here as end style extend. And the reason why you have extend is when you make wires inside a microelectronic circuit, you want to make sure that they overlap at a certain way. So the extend here is given and half of the width normally. You can choose to have a butt end like this. That means that it doesn't extend at all. It just goes exactly to the. So if you're going to make a design that's completely accurate, then you should choose a butt end, because now it's adding another 50 microns on top of the length. So it becomes then 50 microns on either side. So it becomes 3 millimeters, 3.1, isn't it? No, so it becomes 30.1 millimeters then, in a way, this since you're having extended ends. For this design doesn't matter at all, because I'm going to show you later why. But it's just a trick or something you should be aware of if you're going to design this later. So you can also have a rounded like this, or you can have this. So the default is actually having an extend like that. Yeah, that was just a small deviation. The thing was not, or of course in this case you can also just draw a separate line. But for instance, if I just highlight this and I make Control C and then Control V, then there should be a copy now on, I don't know if it's the same spot or not as the old one. And let me see, then if I do this, yeah, it actually pivots around the center line. So if you want to locate it then in the correct position, then you could, there are ways of doing this, but if you're doing this, then you have to redesign everything. But there is also another function called move. And there's actually an M. And the M, press M on the keyboard, you get the move option. And it tells you how much do you really want this thing to move. So you want to move half the distance down. So it will be then, yeah, I don't think we'll be able to do that accurately, but let's say half the distance will be 0.85 maybe in the Y direction. I don't think I want to move the next direction anymore. So 0.85, no, this is millimeters. So 8.5 millimeters. And negative 8.5 should then move it downwards. Okay, this was just a guess from my side. So you can actually move less than that. Let's say you want to move a millimeter at a time. Then it becomes like this, moving. Every time you move it, it will move down. So it's a way that you can coarsely move objects around on the design window. And if you want to be, how accurate you want to be here, then you can always zoom in and you can move it maybe in opposite direction a little bit, and I maybe want to move it 0.1, and then here you have almost hit the right location. If you move then 0.01, right, that was a little bit too far. This is something you can do when you don't really know the coordinates you're going to use. But it's a relatively labor-intensive job to do so, right? And you won't get it 100% correct. But it could be good enough, depends on, again, where you want to position objects in your window. The best thing, of course, is then to go back to Control E and say that, okay, I know my coordinates. I want these to be 0. And 0. And this was 17.3.
Erik, just one question. Why 17.3? Shouldn't the angle be 45 degrees?
No, this is
Then
not
it's-
angle. This is the coordinates. You're
I know,
having the
but like-
start and end coordinates you're putting in.
I know, but if you make the calculations with 45 degrees, you should get 21.21, not 17.3.
Have I done a mistake? And we call this mixer, like this. And here you're going to design then the same manner as I just showed you, the mixing channel. Of course, the dimensions will be different from the inlet channels, but you're following the same methodology as just shown.
The recording has stopped.